You know that feeling when you walk into a status meeting and all the dashboards are just like bright green?
Oh, yeah.
Everyone's high-fiving, but deep down, the code base is held together by duct tape and prayers.
The classic green dashboard, red reality.
Exactly.
Yeah.
And that is exactly where we are living today. We're doing a deep dive into the entire life cycle of software security.
Right.
And I don't mean just a list of tools to buy. We are looking at a stack of sources that covers, well, everything.
It's a fascinating mix. We've got a hardcore DevSecOps pipeline implementation on one hand.
And then these high-level, kind of dry risk management frameworks on the other.
And then the messy human part, the security culture piece that's supposed to bridge that gap.
And that friction is just so palpable in the source material. I mean, we have this DevSecOps final project that builds this beautiful modern pipeline.
And then right there in the documentation, it admits it doesn't actually stop vulnerabilities from going to production.
It's the perfect metaphor, isn't it?
It really is. We have never had better tools, and yet we are, drowning in vulnerabilities.
So let's unpack this. We're going to start in the trenches. The pipeline. The sources lay out a specific GitLab CI/CD workflow designed to, quote, shift security left.
Uh-huh.
Now, I know everyone has heard shift left until their ears bleed, so let's skip the marketing. What is this pipeline actually doing?
Well, the sequence is interesting. It doesn't just run one big security scan at the end. It slices the problem into very specific layers.
Okay.
It starts with secret detection using Git leaks.
Which, frankly, should be mandatory by law at this point.
It really should. Git leaks is just scanning for hard-coded secrets, AWS keys, API tokens, that sort of thing.
And it does this first.
It has to be first. The logic is, if you're committing a credential, nothing else matters. You've already lost.
Right. It doesn't matter if your code is perfect if you just handed the keys to the kingdom to the public internet.
Precisely. Then it moves to linting with ESLint. Now, usually we think of linting as, a style thing.
Oh, you forgot a semicolon.
Exactly. But in this context, it's a security precursor. Messy code, it obscures logic errors. If you can't read it, you can't secure it.
Then we get to the heavyweights. The source highlights a dual approach for SAST static application security testing. They're using SemGrep and SonarQuib.
Yeah.
Why both? Isn't that redundant?
Not really, and that's a pretty nuanced pick by the project creator. SemGrep is lightweight, it's fast, and it's great at finding specific logic flaws.
So developer focus.
Right. And SonarQuib or SonarCloud is more like the heavy artillery. It's looking at code smells, maintainability, deep bug patterns.
I've always loved the term code smells. It's so evocative. It's not a bug yet, but
It smells like one is rotting in there.
Exactly.
A 500-line function with 20 nested if statements, that's a code smell. It's impossible to test securely. Sonar catches that.
Okay, so the code is scanned, then it builds the Docker container, and then we have Trivy.
Right. Because your code might be secure, but if you're running it on, say, an Alpine Linux base image from 3 years ago that has 50 known vulnerabilities, you're still vulnerable.
So Trivy scans the artifact, not just the source code.
Yep. And finally, DAST with OWASP AP. The pipeline spins up the app in a staging environment and actually attacks it.
Kicking the tires while the engine is running.
You got it.
So, on paper, this is the dream. We detect secrets, we lint, we static scan, container scan, dynamic scan. But here is where the source material throws a bucket of cold water on the whole thing.
Yeah.
There is a section in the project documentation called Limitations.
And it is brutally honest.
It explicitly states that despite all this machinery, the security scans are non-blocking.
And that is the critical failure point.
So wait, if GitLeaks finds a password, or Trivy finds a critical CVE, the pipeline turns red, but the build just proceeds.
In this specific implementation, yes. And that's incredibly common in the real world. We set up the tools to report, but we're too scared to let them block. Because if you block the build, you stop the release. And if you stop the release, the VP of product starts screaming at you.
So we've just built a very expensive, very sophisticated notification system.
Essentially, yes. It's security theater. You have the graphs, but you don't have the gate.
But the technical guides we have on SonarQube actually show how to fix this. They talk about the quality gate.
Yes. The quality gate is the contract. It's where you configure the logic that says, if new code has more than 0 critical vulnerabilities, the status is failed. And if it fails,
The pipeline stops.
it stops.
It seems so simple, but setting that threshold is where the politics start, right?
Oh, absolutely. Because the moment you turn that on, you break the build for half the team. Suddenly, technical debt isn't an abstract concept. It's the reason you can't deploy your feature.
There's one other technical nugget in here I want to touch on before we move up, the stack GPG signing for commits.
Ah, yes.
The guide goes into detail about generating keys and verifying identity. Why is this so important?
Because of trust. In a distributed system like Git, identity is surprisingly fluid. I can configure my local Git client to use your name and your email. If I push a malicious commit, it looks like you did it.
That is terrifying.
It is. GPG signing uses cryptography to prove that the commit actually came from the person holding the private key. In a secure supply chain, you don't just scan the code, you verify the author.
It's the digital equivalent of checking ID at the door.
Exactly.
Okay, so let's zoom out. We have the pipeline. It's finding bugs. Hopefully our quality gates are turned on. But let's be real, sometimes a scan finds 500 issues. You can't fix them all by Friday.
And you shouldn't even try. This is where we pivot from engineering to management.
The risk management framework, or RMF.
This is the stuff that usually makes engineers' eyes glaze over, but it's actually the most important part of the puzzle. The RMF source describes it as a blueprint for handling risk.
So it moves us from panic mode to process mode.
Correct. Instead of treating every vulnerability as a fire to be stomped out, you treat it as data to be analyzed.
The source lists 4 specific ways to respond to a risk. And I think these are often misunderstood. The first 2 are obvious: avoid and mitigate.
Right. Avoid is just. You stop doing the risky thing. Hey, this feature requires us to store credit cards in plain text. Okay, let's not build that feature. Risk avoided.
And mitigate is what we do most of the time. Patch the server, rewrite the code, put a firewall in front of it.
Reduce the likelihood or the impact. Then you have transfer, which is usually insurance. Or, in the cloud world, using a managed service.
Like, I don't want to secure this database, so I'll pay Amazon to do it.
You got it. But the fourth one is the controversial one.
Accept.
Risk acceptance.
To a lot of people, accepting risk just sounds like ignoring risk. It sounds like laziness.
It definitely feels that way, especially to the engineer who found the bug. But the source is very clear. Acceptance is a formal process. In government, they call it an ATO, an authorization to operate.
What does that actually look like?
It looks like a senior executive signing a document that says, I understand this vulnerability exists, I understand the potential impact is X dollars, and I'm authorizing the system to run anyway.
That's heavy. That's putting your name on the disaster before it happens.
Exactly. It changes the dynamic. It's not, we forgot to fix this. It's, we decided the cost of fixing it was higher than the value of the asset.
The cost-benefit analysis. The source has a great example. If the asset is worth $10,000, but the security control costs $100,000.
You don't spend $100,000 to protect a $10,000 asset. That's just bad business. You accept the risk. You're betting you probably won't lose the 10 grand.
And even if you do, it's still cheaper than the fix.
Right.
But this implies you actually know what the loss would look like.
And that's the trap. The RMF source stresses metrics. You need an ALE, an annualized loss expectancy. You need a heat map. If you're accepting risk based on a gut feeling, you aren't managing risk. You're gambling.
So we have the pipeline shouting about bugs. We have the RMF deciding which ones we can live with. But who is actually doing the work? Who navigates this tension?
The humans.
Yeah.
And that brings us to the security culture presentation.
This is my favorite part of the stack because it deals with the psychology of why this stuff fails. It opens with a meme. I love that we're analyzing memes now, of a developer drowning in the ocean.
And a security guy on a boat just high-fiving him.
Yes.
It's the perfect visualization of uncontextualized vulnerabilities.
Uncontextualized vulnerabilities. Break that down for me.
Okay, imagine I walk up to your desk and I just drop a 400-page PDF on your keyboard. It lists 2,000 issues. Some are critical, some are false positives, some are irrelevant. And I just say, fix this.
I'm quitting. I am walking out the door.
Exactly. That isn't security. That's just noise. The developer doesn't have the context to know what matters, so they ignore all of it.
So how do we fix the drowning developer problem? The source pitches the idea of security champions.
This is a strategy to scale. You can't hire enough security engineers. The ratio is usually crazy, like 1 security person for every 100 developers.
You'll lose that battle.
You'll always lose. So you deputize. You find developers on the engineering teams who have an interest in security. You train them, you mentor them, and they become the champion for their squad.
But the source has a warning here. It says this fails if you just treat it as extra work.
Oh, it's the fastest way to kill the program. Congratulations, you're the security champion. Here's 10 hours of extra work a week. No, you don't get a raise.
Yeah, that's a recipe for burnout.
The program only works if it's recognized. Give them swag, give them a title, put it in their performance review, make them the hero who translates security speak into dev speak.
Speaking of translation, there's another group the source says we're ignoring, QA.
Yes, empowering quality assurance.
I hadn't thought about this, but QA teams already know the application better than anyone. They spend all day trying to break it.
They do. And the source makes this brilliant comparison. A standard QA test case is log in as user A and try to see user E's profile. Right. A security test case is log in as user A, change the ID in the URL to user B, and see if you can see user B's profile.
That's the classic IDOR vulnerability. Insecure direct object reference.
And it's such a tiny shift in mindset. If you teach your QA team that one trick tests the negative, suddenly you have a security testing team embedded in your release cycle without buying a single new tool.
I love that. Use the resources you already have. Now we have to talk about the watermelon.
The watermelon metrics.
The source warns about watermelon dashboards. Green on the outside.
Red on the inside. This is the most dangerous thing in corporate security.
Give me an example. How do I fake a green dashboard?
Easy. Let's say your metric is time to fix critical vulnerabilities, and your SLA, your deadline, is 30 days.
Okay.
So on the dashboard, you track bugs breached SLA. As long as that number is 0, the dashboard is green.
Sounds good to me.
But what if you have 500 critical bugs that are 29 days old?
The dashboard is still green.
Correct. Or what if you just never triaged the bugs? If they sit in the new queue, maybe the clock hasn't even started ticking yet. So you have a mountain of risk, but your dashboard says compliance, 100%.
That's the watermelon. You cut it open, and it's bleeding red.
And executives love watermelons. They look great in board meetings, but they mask reality until you get hacked.
So what's the alternative?
The source argues for maturity models, things like OWASP, SAM. Measure your capability, not just your activity, and make the dashboards visible. The dashboard rule in the text says, if the developers can't see the score, they can't improve the score.
Transparency is the best disinfectant.
It is. If a team sees they have a D grade on security, their competitive instinct kicks in. They want to get to a B.
So putting it all together, it's an ecosystem.
It is. The pipeline, GitLab, Sonar, Trivy that provides the raw data. It tells you the truth about the code.
The RMF provides the decision logic. It tells you whether that truth is an acceptable risk or if it's a showstopper.
And the cultures, the champions, the QA testers, the honest metrics, that ensures the system actually works.
Right.
Without the culture, the pipeline is just noise and the risk acceptance is just paperwork.
You need all three. If you just buy the tools, you're doing security theater. If you just do the RMF, you're doing bureaucracy. If you just do culture, you're just vibes.
Vibes are not a security strategy.
Before we go, I want to circle back to one thing from the risk management section that's been stuck in my head. We talked about accepting risk, about signing that paper.
Yes, the get out of jail free card.
The source has a very specific warning. Accepted does not mean deleted.
That is the thought I want everyone to leave with. Risk acceptance has an expiration date, usually 6 to 12 months.
Why? If I accepted it today, why isn't it accepted next year?
Because the world changes. Maybe that library you used is now way easier to exploit because some script kiddie posted a tool on GitHub.
Or maybe your user base grew from 1,000 to 1 million, so the impact of a breach is now huge.
Exactly.
So acceptance isn't a permanent pass. It's a snooze button.
It is a snooze button. And we all know what happens if you keep hitting snooze. Eventually, you're late. In this case, eventually, you're breached.
So here is the question for you, listening right now. Look at your risk register. If you even have one, look at those accepted risks. Are they actually managed risks that you review every 6 months? Or are they just ticking time bombs that you formally agreed to ignore?
Check the expiration dates.
On that note, thanks for diving deep.
Stay safe out there.
Let's see you next time.